Idle airflow adjustment procedures for 1991 model year sludge-tolerant throttle bodies. This video presentation will introduce the various throttle bodies and idle airflow adjustment procedures for the 1991 models. The 1991 engines use die-cast aluminum single and dual-bore throttle bodies for air intake. All throttle bodies, with some exceptions, include a sludge-tolerant feature. The sludge-tolerant design is a special coating on the bore and bottom of the throttle plate. This coating helps prevent some idle problems common to throttle bodies. Throttle bodies without the sludge-tolerant feature position the throttle plate slightly open at idle. This opening supplies most of the air needed to maintain engine idle speed. The idle air bypass channel and idle speed control solenoid supply the remaining air for idle operation. After some time, the throttle plate opening becomes blocked by carbon and oil, commonly referred to as sludge. This changes the original factory-set idle airflow. The coating on the sludge-tolerant throttle body seals the throttle plate and bore gap at idle. The throttle plate orifice, or idle air trim passageway, supplies most of the air for idle. These passages resist sludge buildup. The idle air bypass channel and idle speed control solenoid supply the remaining air for idle operation. This results in a long-lasting, smooth idle and eliminates the need for cleaning the throttle body bore. The idle speed should only need adjusting in extreme cases after verifying that all other idle-related systems have been checked and function properly. Yellow and black attention labels identify sludge-tolerant throttle bodies. The labels state not to clean these throttle bodies due to the special coating. Cleaning can damage the sludge-tolerant coating, eliminating the benefit from it. Throttle bodies without the sludge-tolerant feature require periodic cleaning. This would be limited to the 1.9-liter SEFI Escort Tracer, 2.9-liter EFI Ranger, 5.0-liter SEFI Grand Marquis Crown Victoria, and 7.5-liter EFI F-Truck and E-Van until mid-year. Refer to the Engine and Emissions Diagnosis Manual for the procedure to clean this type of throttle body. A service feature on the sludge-tolerant throttle body is the adjustment of idle airflow. The means for adjusting idle airflow depends on the type of throttle body used. On a throttle body without the sludge-tolerant feature, idle airflow is corrected by periodic cleaning. The idle stop screw should not need adjusting. Idle airflow on a sludge-tolerant throttle body can be adjusted by turning either an idle stop screw or an idle air trim screw. These should only be adjusted in extreme cases, since adjusting either screw defeats the benefit of the sludge-tolerant feature. The color of the attention label on sludge-tolerant throttle bodies identifies the type of screw used for idle speed adjustment. A throttle body having a black label with yellow lettering uses the throttle stop screw. A throttle body having a yellow label with black lettering uses the idle air trim screw. The idle air trim screw is located behind a plug on the throttle body. To access this screw, remove the plug using tool number T71P-19703-C or equivalent. Turning the screw requires the use of a 1/8-inch Allen wrench or a special offset Allen wrench, tool number T71P-9550-A for the 4.6-liter engine. Some idle adjustment conditions on sludge-tolerant throttle bodies with the throttle plate orifice require the installation of a throttle plate orifice plug. To install this plug, remove the air inlet ducting from the throttle body. Use the gauge pegs included with the service kit FOPE-9F652-AA to determine the correct size plug. These pegs are go-no-go gauges that match the various orifice sizes. Try inserting the gauges into the orifice. Start with the largest gauge and work toward the smallest. The largest gauge that fits indicates the size of the plug needed. Use the plug with the color that corresponds to that gauge. Install the plug using the tool in the service kit. Push the plug into the orifice until it bottoms out on the throttle plate. Snap the throttle several times to ensure the plug is secure. Most idle conditions are caused by concerns in other engine-related areas. These areas include the fuel system, air bypass solenoid, throttle linkage, ignition system, ignition timing, PCV and EGR systems, cooling system, and vacuum leaks. An idle airflow adjustment will not compensate for problems in these areas. Check these areas before assuming the idle airflow needs adjustment. All throttle bodies require the use of a certain procedure for adjusting idle airflow. There are 4 idle airflow adjustment procedures labeled A, B, C, and D for the 1991 vehicles. The first step is to identify the procedure that applies to the vehicle being worked on. Refer to the chart in the Engine and Emissions Diagnosis Manual to identify the procedure needed for a certain vehicle. To prepare for an idle airflow adjustment, make sure the transmission is in park or neutral. Apply the parking brake. Block the wheels. Make sure the engine is at normal operating temperature. Turn off all accessories. And check ignition timing. Test the EEC4 system for fault codes and resolve any that are present. If the idle condition still exists, continue with the idle airflow adjustment procedure. Procedures A and C apply to passenger cars and trucks with self-test idle speed check provisions. Some applications require the use of more or less steps. Always consult the Engine and Emissions Diagnosis Manual and do the steps that apply to the vehicle being serviced. To begin, activate the engine running self-test. After code 11 or 111 has been displayed, wait 4 seconds and then quickly cycle the STI button off and on. A single pulse code indicates entry into self-test idle air adjustment mode. The star tester will now indicate what adjustment is needed. A constant tone, solid light, or stow-low readout means the base idle RPM is within range. A beeping tone, flashing light, or stow-low readout 8 times a second means the throttle position sensor is out of range and may require service. A beeping tone, flashing light, or stow-low readout 4 times a second means the base idle RPM is too fast. A beeping tone, flashing light, or stow-low readout once a second means the idle RPM is too slow. If the idle speed is too slow, turn the throttle stop screw clockwise or the idle air trim screw counterclockwise until the star indication is correct. Note, turning the throttle stop screw counterclockwise should be avoided. This can cause the throttle plate to stick in the bore. The only time that a counterclockwise adjustment should be needed is on applications that were adjusted before. A previously adjusted throttle body can be identified by the throttle plate orifice plug already being in place or a broken throttle stop screw paint dot. Use care when turning the throttle stop screw counterclockwise. This can cause the throttle plate to stick in the bore. When it is necessary to adjust the throttle stop screw counterclockwise, make sure the screw and lever pad are making contact after the adjustment. On applications with an idle air trim screw, a clockwise or counterclockwise adjustment can be performed without a problem. If the idle speed is too fast on sludge-tolerant throttle bodies with the idle air trim screw, turn the trim screw clockwise until the proper idle speed is reached. If the idle speed is too fast on sludge-tolerant throttle bodies with the throttle plate orifice, turn the engine off and securely install a piece of tape to completely seal the throttle plate orifice. If the throttle plate orifice plug has already been installed, proceed to the TPS output code test. Restart the engine and check idle speed using the self-test function. If the idle speed remains fast, check for a correct throttle position sensor output code. An out-of-range indication requires diagnosis of the throttle position sensor. Refer to the Engine and Emissions Diagnosis Manual for the correct procedure. A correct throttle position sensor code requires looking for another cause of the fast idle condition, such as a fuel or ignition system malfunction. If the idle speed is at or below the proper speed with the tape in place, turn the engine off. Remove the tape from the throttle plate and install a throttle orifice plug using the procedure in the Engine and Emissions Diagnosis Manual. Now, adjust the idle speed by turning the idle stop screw clockwise. The next step is to run the key on engine off self-test to check for a proper TPS output code. Verify the throttle is not stuck in the bore and the linkage is not binding or preventing the throttle from closing. This should be done with the engine off and with the engine running. On automatic overdrive transmission applications, check the throttle valve pressure adjustment. Procedures B and D apply to passenger cars and trucks with no self-test idle speed check provisions. Some applications require the use of more or less steps. Always consult the Engine and Emissions Diagnosis Manual and do the steps that apply to the vehicle being serviced. To begin, disconnect the negative battery terminal for 5 minutes, then reconnect it. Start the engine and allow it to idle for 2 minutes. Goose the throttle and let it return to idle. Lightly depress and release the throttle and note idle quality. If the engine does not idle properly, continue with the procedure. Disconnect the idle air bypass solenoid. Start the engine and run it at the specified RPM and time period. Using a tachometer, compare the idle speed to specifications. If the idle speed is too slow, adjust the throttle stop screw clockwise to increase it. If the idle speed is too fast, turn the engine off and securely install a piece of tape to completely seal the throttle plate orifice. If the throttle plate orifice has already been installed, proceed to the TPS output code test. Restart the engine and check the idle speed. If the idle speed remains fast, check for a correct throttle position sensor output code. An out-of-range code may require diagnosis of the throttle position sensor. Refer to the Engine and Emissions Diagnosis Manual for the correct procedure. A correct throttle position sensor code requires looking for another cause of the fast idle condition, such as a fuel or ignition system malfunction. If the idle speed is at or below the proper speed, turn the engine off, remove the tape from the throttle plate, and install a throttle plate orifice plug according to the procedure in the Engine and Emissions Diagnosis Manual. Now, with the engine running, adjust the throttle stop screw to the specified idle speed. The only time that a counterclockwise adjustment would be needed is on applications that were adjusted before. A previously adjusted throttle body can be identified by the throttle plate orifice plug already in place or the throttle stop screw paint dot being broken. Note, use care when turning the throttle stop screw counterclockwise. This can cause the throttle plate to stick in the bore. When it is necessary to adjust the throttle stop screw counterclockwise, make sure the screw and lever pad are making contact after the adjustment. Now, shut the engine off and disconnect the negative battery terminal for 5 minutes. Then hook up the battery and run the key on, engine off self-test to check for a proper throttle position sensor output code. Now, reconnect the idle air bypass solenoid. Verify the throttle plate does not stick in the bore and the throttle linkage is not binding. This should be checked with the engine off and with the engine running. Finally, on automatic overdrive transmission applications, check the throttle valve pressure adjustment. This concludes the video presentation on throttle bodies and idle airflow adjustments for the 1991 models. If you still have questions on these procedures, refer to the Engine and Emissions Diagnosis Manual for additional information.